Hello everyone, I'm Lucian, an AMD GPU DevTech engineer working at AMD Shanghai office. Today, I'll introduce our TrustFX new version in UE4, TrustFX 5.0 version. Our last version is 4.1, but it has many limitations. We have made many improvements from that version, both simulation and rendering. Let's look at this agenda. If you have tried to integrate the 4.1 version in UE4, you would have encountered some limitations, such as tools were not easy to use, simulation didn't work well, and the rendering effect didn't look good enough. In UE4 TrustFX 5.0 version, many improvements have been made to break all these limitations. In integration part, I will introduce the folder structure of 5.0 version and the steps to integrate to UE4. After integration, it's also important to know how to use the new version, such as how to use the new editors and how to create and set the TrustFX materials. Last but not least, I'll talk about the future work of next stage. Many developers have given us feedbacks about the difficulties they met when they tried to use UE4 TrustFX 4.1 version. Let's look at these limitations. In terms of exporter, if your animation is complicated, some vertices bind more than 4 bonds, it means you can directly use TrustFX because the exporter limits the number of binding bonds to 4. If you export the asset from some keyframe, it may result in strands and clear mesh skin twice in UE4. And it's really hard to check what went wrong because it lacked asset editors and visualization tools. If you export asset correctly and import to UE4 correctly, you may also encounter some simulation limitations, especially when you turn on SDF. SDF means signed distance field. SDF could be used to avoid penetration for some long-hair female characters. Long hair is easy to penetrate into the body. As for the rendering part, I have to say the rendering effect was not good enough and was not compatible to Unreal Pipeline very well. There was also no support for so many rendering features, and resource management was not reasonable enough. According to developers' feedback, there were difficulties when they tried to use TrustFX cleaner feature as well. Look at the TrustFX mesh, strands, the bounding box of TrustFX clear mesh. The bounding box doesn't cover all of the TrustFX mesh. SDF is computed based on the bounding box, and it should be inside the bounding box. But the yellow area doesn't seem correct. The yellow area is SDF voxels. There are many reasons which would cause this issue, like exporter, clear mesh computation, SDF computation. We should find the exact reason, find a way to check and validate. This is another big limitation according to our developers' feedback. This asset is our official RadBoy asset. The green wireframe mesh is TrustFX clear mesh. The solid mesh is UE4 skin mesh. Obviously, they are not at the same position. Look at the hand and the tail of RadBoy. In TrustFX simulation part, strands and clear mesh use the same animation data. It looks like animation data used for simulation lags a frame behind the UE4 skin mesh animation data. It's truly of great importance. We have worked hard to check and overcome all these limitations. Here comes our UE4 TraceFX 5.0 version with all these improvements we are expecting. As I said before, there are many reasons which would result in these limitations. So first, we should prepare simple Maya asset for test. To check step by step, we should start from the exporter. Check whether it's correct after it's imported in UE4. If asset is correct, we should validate the clear mesh computation. As I said before, SDF is computed based on clear mesh, so we should confirm that clear mesh is correct before we compute SDF. But when we try to debug some simulation issues, it's not easy to reproduce or check because some animations play so fast, we couldn't see it clearly. So we should find a way to reproduce it and check frame by frame. Here, the way we reproduce it is to make a video in UE4. After clear mesh computation is correct, we should validate the SDF computation, and it's the final step. This is the asset which we have found the SDF info is incorrect after it's imported in UE4. In order to find the exact reason, we should start to check from this step. The left image and the right image are two keyframes. The difference between the two keyframes is that the first keyframe keeps the original mesh positions unchanged after binding bonds. We should try to export from each keyframe and check whether it's correct in UE4. After it's imported in UE4, we should check whether the clear mesh is correct. But UE4 doesn't support any TraceFX visualization feature by default. So we need to implement the clear mesh visualization in UE4 to confirm whether the clear mesh and the strands positions are the same to Maya. We have implemented complete clear mesh visualization. If you want to turn on this feature, double-click Radboy TraceFX Mesh asset to open TraceFX Mesh Editor. You can turn on clear mesh visualization by enable visualize mesh. After enable clear mesh visualization in TraceFX Mesh Editor, you can see in the level map editor at the same time. It's now convenient to check since we have the visualization tools. If we export from the second keyframe, both the strands and the clear mesh would be scanned twice. Obviously, that should be one of the reasons which may result in SDF incorrect. We should export from the first keyframe, which keeps the original mesh position unchanged after binding bonds. After this step, clear mesh is correct, but still we are not sure whether the SDF computation is correct. More works should be done to check and validate. Now we could visualize and validate clear mesh. It's time to improve animation data used for simulation lags the frame behind UE4 skin mesh animation data. At first, we found it not easy to reproduce because the animation plays very fast, we couldn't see it clearly. If we change some codes and wanted to check whether it has been fixed, it's also not easy to validate. Finally, we found a way, that is to make a video by UE4 sequencer. In the video, we can check frame by frame, which is very convenient and efficient. We should get the Born matrix of TraceFX simulation from the right place. Now, it has been improved. Look at the difference between the left and the right, the body and the tail of rat boy. TraceFX clear mesh and the UE4 skin mesh are at the same positions now in the right image. Let's go back to improve the SDF info incorrect. As I said before, now we could confirm clear mesh is correct, but still need to check the SDF computation. Obviously, we also need a way to visualize the results of SDF info, which UE4 doesn't support by default. The method we used is just like per pixel linked list algorithm. We call it per voxel linked list. It's a 3D version of per pixel linked list. Now bounding box is computed on GPU side. The white line is bounding box. Previously, it's computed on CPU side. For some complicated animations, it's not accurate enough. We have implemented SDF visualization and asset editor. You can turn on SDF visualization by enable Visualize SDF. We can visualize both in asset and level map editors. We can edit the resolution of SDF cells. After this step, we could confirm and validate if SDF computation is correct. And it's time to improve the SDF info incorrect limitation. Now let's look at the SDF avoid penetration feature. The left image is SDF off. Look at the head and the shoulder of rat boy. Many strands penetrate into the body. The right image is SDF on. The strands are still out of the body. We can use this feature to avoid penetration. At first, my understanding of SDF is that it can be used to avoid penetration in some long hair cases. But SDF can not only be used to avoid penetration, it also can be used to implement the strands interact with hands. Look at the small hands of rat boy, left hand and right hand. So it means we can implement the interaction for both long hair and short hairs. Maybe we can implement more interesting feature by SDF. So far, we have presented our SDF improvements involving editors and new effects. And now, I'd like to talk about the new resource management, which plays a major role in the realization of our improvements. Reasonable resource management is very important to implement editors and all other features. Here, we have two main classes, TraceFX component and the TraceFX group instance. In TraceFX group component, we generate and register TrustFX group instance in init resources, and unregister and delete in release resources. In TrustFX group instance, it has a member world type to handle different kinds of editors, like asset editor, level map editor, and blueprint editor. TrustFX has different types of buffers which need to be managed. Some buffers store static data, some buffers store dynamic data. Some buffers are used to do rendering, and we do simulation and the rendering for each TrustFX group instance. In this section, I will talk about rendering improvements. In 4.1 version, we use shortcut as the rendering solution. Shortcut needs to shade 3 layers by default, but the new solution just need to shade 1 layer. In 4.1 version, shading model is Kajia, but now we use UE4's hair shading model. For deep shadow, we try to reduce the layers of fragments which should be written to texture. Strand UV feature is a useful feature. We have supported strands root UV and strand UV feature in UE4 material editor. Developers can implement more complicated effects by this feature. And now we support TAA. As for shortcut simplification, let's look at the difference between default blend formula and the shortcut blend formula. The default blend formula is easy to understand, but it needs to sort all the fragments for each pixel. Our shortcut is order independent. It has 2 main passes. The first main pass generate texture 2D array, depth info, and translucency info. The other main pass implements lighting and shading for fragments and accumulate to render target. Shortcut shades 3 layers by default. After the shortcut simplification, we still generate translucency info, but we don't generate depth info and just shade the first layer. This way, we don't need to store too many material data. Regarding shading model, we directly use UE4's hair shading model. The new shading model needs the hair count info, which is generated by deep shadow paths to do global scattering. But hundreds of layers of texture I/O may happen to many pixels. That's really performance expensive. We use per pixel linked list to randomly sample 20 layers to approximate the total layers. Now we have supported strands root UV and the strand UV feature in Unreal Material Editor. We implement this in TrustFX Vertex Factory shader. Look at the struct F Vertex Factory interpolance VS2PS. It has a member texture coordinates array. We pass root UV and strand UV to this member. Root UV is called from root UV buffer, which needs a strand ID. This member will be passed to calculate pixel material parameters in Pixel Shader. We have refactored the main flow of TrustFX in UE4. Simulation part is between init views and base paths. Now we compute the bounding box of clean mesh on GPU side in the past process SDF generation. To support strand UV feature, we generate strand ID buffer in the path process strands interpolation. As for rendering part, TraceFX should support default shading pipeline. It has TraceFX prepass to generate shadow info and the TraceFX base pass to generate translucency. Material data such as base color, roughness, specular are prepared for the new shading model, and you can use strand UV feature to generate more interesting base color. It also updates the velocity buffer to support TAA. In the past render lights, we now support cast and receive shadows very well. We implement the shading and the lighting based on the new shading model and support skylight in render environment light. Here is the overview of improvements in 5.0 version. As for the exporter, now we support the number of binding bonds up to 16, and developers should be clear about how to select the right keyframe before export. And we have implemented different types of editors and the visualization tools. We have fixed previous simulation limitations and improved SDF feature. For rendering part, we now support many features, and what's more important is that the resource management is more reasonable. So far, I have introduced all the new features of 5.0 version in UE4. But how to integrate in UE4? I like to introduce the folder structure of 5.0 version. Look at the left top image. It's all the folders of 5.0 version. Let's open the asset folder. We can see the RadBoy assets which have been imported to UE4. All the source codes are in the engine folder. Let's open the engine folder. We can see the plugins, shaders, source folders. In the shaders folder, we just changed one engine shader, the material template shader. In the source folder, we changed a few engine files. In these engine files, we have AMD TraceFX begin, AMD TraceFX end segment to mark where was changed. Here are the steps to integrate in UE4 26.2 version. If you didn't change any UE4 source code, you can directly copy the engine folder to your local engine folder and replace it. But if you change some engine files, you can copy the code segments AMD TraceFX begin, AMD TraceFX end, which I said before, to corresponding places. After that, you can double-click Generate Project Files and recompile UE4. Run the engine and create a new project with starter content. Before copy the asset to the new project, please enable the TraceFX 5.0 plugin in Plugin Manager. You can open the New World level map and see the RadBoy. The lights, except the skylight, should enable cast deep shadow before TraceFX could render correctly. After integration, I'd like to share you with more details about how to use in UE4. In this section, I'll introduce how to create and set TraceFX materials, and then share more details about Asset Editor, TraceFX Asset Editor, and the TraceFX Mesh Asset Editor. The last part of this section is how to use TraceFX assets in Blueprint Editor, like how to turn on, turn off SDF. In TraceFX material section, after select the result node of the material, set material sheeting model to hair, and set enable used with TraceFX. We recommend naming your TraceFX material with the prefix TFX matte. Now we should generate the base color. Let's look at the texture coordinates 0 and 1. We can use texture coordinates 0 and 1. Texture coordinate 0 and 1 correspond to texture coordinates array in TraceFX Vertex Factory Shader. Texture coordinate 0 stands for strands root UV, and the texture coordinate 1 stands for strand UV. You can use these two UVs to generate more interesting base color. Now let's look at TraceFX Asset Editor. It's about the TraceFX strands. Double-click Ratboy Fur asset to open Asset Editor. It has 4 panels on the right. The first one is Material panel. You can choose and set TFX matte Ratboy material. In the Strands panel, we can control the strand's width, number and distribution radius of follow hairs dynamically. In the LOD panel, you can set each level based on the screen size, which is the bounding box of TraceFX component projected on screen size. In the simulation panel, you can first set global shape, stiffness, and range. And now the local shape stiffness is curve editor. We offer 3 VSP parameters to control move too fast or constant speed situations. By default, wind magnitude is 0. There is no wind by default. This is TraceFX Asset Editor. It's mainly about clear mesh and SDF. I have introduced how to use SDF before. We can double-click Ratboy Mesh asset to open it. In clear mesh part, we can enable Visualize Mesh and enable Visualize Mesh ABB. And we can see in the level map editor at the same time. Now let's look at TraceFX Blueprint Editor. We should use our TraceFX asset and turn on SDF here. After attaching TraceFX component to skeletal mesh, you can set TraceFX asset and set local SDF ID reference to enable SDF clearance feature. Local SDF ID reference is corresponding to TraceFX SDF component local SDF ID. After attaching TraceFX SDF component to skeletal mesh, You can set TraceFX mesh asset, enable SDF, and set local SDF ID to turn on SDF. At last, I'd like to show you a short video in UE4. Open the Radboy material, click the result node, and set shading model to here. Enable used with TraceFX. Here, let's look at texture coordinate 0 and 1. Texture coordinate 0 is root UV. Texture coordinate 1 is strand UV. You can use these two UVs to generate more interesting base color. Now let's open TraceFX Asset Editor. It has 4 panels. In Material panel to search and set TraceFX material. In Strands panel to control strands width and follow here. In LOD panel to set screen size and strands decimation of each level. In Simulation panel to enable simulation, and you can use the curve editor to edit local shape stiffness. Now let's open TraceFX Mesh Asset Editor. You can enable the clear mesh and bounding box visualization. And the mesh bounding box. And you can enable SDF visualization and edit the resolution. Now let's open Blueprint Editor. Attach TraceFX component and set TraceFX asset. Attach TraceFX SDF component and set TraceFX mesh asset, and enable SDF and set local SDF ID. Then you can set local SDF ID reference in TraceFX component to turn on SDF. Yeah. Many improvements have been made, but we still have a lot of work to do in the future. Current version is for UE 426.2. We already have plans to support UE 427 and UE 5. Next stage, we will support blend shape vertex animation and try to research more about rendering optimization, such as feather optimization for deep shadow. If you want to customize any features of 5.0, please contact our DevTech team in your region. It's all for today's presentation. Hope it will be useful to your project. Thank you.